Right. So, hello everyone and welcome back. So, today we will be deriving yung ating temperature distribution in a cylindrical system. So, ayun nga, this is just related dun sa ating uh, cylindrical coordinates yung derivation on. So, as we can see here, before we look at the figure na nandito. So, first we apply yung ating core pertinent assumptions, which is yung ating uh, constant properties, steady state conditions, no internal heat generation, and yung ating one-dimensional uh, conduction. No? So, ayan. So, for the one-dimensional, ang pinili ko na lang is yung, the most simple one is yung ating r direction for cylindrical coordinates. So, if you chose that, you will have this equation, which is 1 over r, d over dr. Hindi na siya partial derivative since you only have one variable at this point. Okay? So that's kr and then dt over dr equals 0 since, ayun nga, we applied our four assumptions. And then, uh, ang goal natin dito is to devise an equation that will adhere to this figure here. So, what does this figure mean? So, it is basically a cross-sectional area ng isang cylinder. No? So, it's a surface, but yung ating cylinder has an inner and an outer radius. No? So, that's the general meaning here. And at those specific points, meron ding respective na temperature na dito. So, let's say for R1, we have TS1. And for R2, we have TS2. So, ang goal is to devise an equation uh, uh, as a function of T. Ano? T as a function of R, in which we can find temperature at any given point within the radii. Ano? So our radius will um, be between R1 and R2. Okay? So, ayun. If you have done yung ating example 3.4, so uh, that will be much better since it's the same process basically. Ayun. So let's start. So first, uh, we have to make another assumption here. No? So it is that, di ba, wala tayong K. No? So K is not there now. No? So since constant properties nga siya, so we can transfer K dito sa ating constant here and then we can cancel them both. No? So ayun, then we will end up with this equation. D over dr um, r dt over dr is equal to 0. And now, what we have to do is we have to separate yung ating variables. Okay? So, we just basically multiply dr to both sides, and then we have d of r dt over dr is equal to dr. Ayan. And then, we can just integrate both sides. So, yeah. So, again, we're still not putting any limits of integration yet. Since mag-apply tayo ng boundary conditions, so it's fine if we don't put any limits yet. No. So, but if you want to, you definitely can. So, I'll leave that up to you if you want to do that. So, yeah, if you integrate this, this will just cancel, and this will just be R. So, ayun, if you actually, this is a constant, so it's gonna be a C. Okay, so R dt over dr is equal to C1. No. And then, again, we have to isolate yung ating variables. So, that will be dt over dr is equal to C1 over R. No? And then, uh, separating, i-isolate pa rin natin yung ating dt. So, it will be dt. And that will be, ilabas natin yung ating constant, that is C1. And we have dr over R. Again, we are ready to integrate yung ating expression. So, integrating both sides. So, the integral of dt is just another constant, and dr over r is the natural log by the definition. of 1 over x. Dx is equal to the natural log of x. But now in terms of r. Ayun. And therefore, ating t, no? Ating t is equal to uh, C1. Ating C1. And then, multiply natin sa nakuha nating integrals. Nakuha natin sugat. So, it is ln of r, no? Plus C2. Ayan. And this is our general solution. And so this is general solution for this second order DE. And now we have to apply yung ating boundary conditions. So, applying yung ating boundary conditions. Okay. So, we have two conditions here. So, at R, no, at R equals R1, no, then our T is equal to TS1, as you can see in this figure. No. If we have R1, then the temperature is at TS1. And at R equals R2, then most definitely T is equal to TS2. So, ayun. And now, we substitute yung ating values here. Okay? So, for TS1, we just use the same expression here. So, ayan. FC1 plus ln R. Ano? And now, since we have R equals R1, so it's R1. Plus, ano ba? Plus C2. So, this is actually a product. My apologies. Ayan. And for TS2, no? So, it will be C1 ln R. Now, it's R2 plus C2. Ayan. And we solve for C. So we're solving for C. So, ayan. So, let's have C2. No? Let's C2. That's equal to TS1. So, kunin muna natin nandito. TS1 minus C1 ln R1. And for the second one, that is TS2 minus C1 ln R2. Ayan. And we equate this. No? We equate this. And we solve for C1. So, equate natin siya. Yan. S1 minus C1 ln R1 is equal to TS2 minus C1 ln R2. Ayan. And then, we rearrange to solve sa ating C1. Okay? So, first, we subtract to TS2 from both sides. So, TS1 minus TS2. So, mawala na ito dito. Right? And that is equal to C1. And then, you could just factor out since we have C1 on both sides. Factor out natin yung ln. So, ln R1 minus ln R2. Ayun. And again, from the laws of logarithms, ln A minus ln B is just equal to ln of A over B. Ayun. So, we rewrite the equation will be C1. Now, we have the ln of R1 over R2. Ayun. And solving for C1, we just divide both sides by the expression ln R1 over R2. So, we'll just cancel each other out and then pupunta yung dito. Therefore, ang ating C1 is going to be equal to TS1 minus TS2 over yung ating ln of R1 over R2. Yun, right? So it's been coming along so far. And now we will use this. No? So we have C1 and we have C2, right? We have C1 and C2. We substitute that to our general solution. No? So i-rewrite lang ulit natin. Now we have T as a function of R. That's equal to, again, C1 ln R plus C2. Okay? And para hindi tayo magkalituhan, isubstitute mo natin yung ating C2. So we have Cn ln R plus ng ating C2, which is Ts2 minus C1 ln R2. Ayan. So, simplify natin further. So we have C1. And now, again, we have a difference in sa ating logarithms, right? Yeah. Since it's both a factor of C1, so we will have ln of R over R2. And we have plus S2. Ayan. And now we have another C1. So ngayon, i-substitute na natin yung C1 na nandito. Okay. Therefore, ang ating T of R that is equal to, substitute natin, we have Ts1 minus Ts2 all over. So we have ln of R1 over R2 multiplied by the rest of the expression here. We have ln of R over R2 plus yung ating test. Yun. So this is our temperature distribution for a cylindrical system. Ayan. So sulit lang natin. Yun. And now, there are other expressions or equations that is used here. So when we have temperature distribution, of course, we have yung ating heat transfer in the form of conduction, as well as thermal resistance. So we will also derive those equations here. So madali lang naman siya. It will just take a bit here. So, okay. Let's move on sa ating next. So, punta muna tayo sa ating heat transfer. So, it's in terms of yung ating Q of R sa ating radial coordinates. Right? And now, let's say I have a cylinder. So, last time we looked at the cross-sectional area. Now, iba naman yung titingnan natin. Ayan. So, cylinder, of course, has a length L and a radius R. Now, when we have an L, we are presuming that we are taking its circumferential area. No, so ang consider din natin dito is yung ating circumferential area. So, for heat transfer, conduction, Fourier's law. QR is equal to negative Ka dt dr. Yun. But we are considering yung ating circumferential area. And for yung ating area, that will be 2 pi RL. Yun. And we substitute this sa ating equation. So we have QR. This is just going to be negative K 2 pi RL dt over dr. Yun. And again, we can arrange this. No, we can rearrange to solve for the heat transfer. So, ang gawin natin is we just divide both sides by writing 2 pi L, and then we can isolate dt. So that will be QR over, we divide by 2 pi L. So yung R, sasama natin sa dr, no, sasama natin sa dr to integrate it. So that would be dr over R. No? And that's equal to negative k dt. And again, so now we have a familiar looking equation, and now we integrate both sides. Ayan. And applying yung ating limits. So this is from R1 to R2. Ano? And this is from this one to this 2. So again, we're applying the same boundary conditions that we used here. Yung ginamit nating boundary conditions. That is just the same. Now in the form of the limits of integration. Integrating, so copy lang natin yung constant, QR over 2 pi L, and then integral of dr over R is ln of R. Then apply natin yung ating limits, that is from R1 to R2 is equal to negative k, and we have S2 minus TS1, right? And simplifying, so we have QR over 2 pi L, and now we have ln of R2 minus ln of R1 is equal to copy lang natin. We will simplify this later, so para lang hindi tayo malito. Ayan. And again, applying the laws of logarithms, this is just ln of R2 over R1. So let's do that. So QR over 2 pi L, this the ln of R2 over R1. That's equal to negative k ts2 minus ts1. Now, we are going to isolate QR. So what we can do is multiply both sides by 2 pi L. And what else can we do is divide both sides by the ln of R2 over R1. Ayan. So let's just fix this. Ayan. So this will cancel, and this will cancel. Yeah. So what we have now is getting Q of R that's equal to 2 pi L times K. No. Then we have ts1 minus ts2 all over ng ating ln of R2 over R1. So this is our heat transfer in a cylindrical system, heat transfer rate. So, and let's just box this. So natin. Kailangan na natin yung box. Okay. Yeah. So this is our heat transfer rate in a cylindrical system. Yeah. And finally, we have our yung ating resistance. So, yung ating resistance, nasa module natin is R of T conduction. And in general, yung formula ng ating thermal resistance, that is just your temperature difference over your heat transfer rate. So that is Ts1 minus Ts2 all over QR. And now we simply do is substitute yung ating value ng QR dito. Okay, so let's just do that. So when we substitute this, yung nasa denominator natin is may reciprocate into the numerator. Okay, so instead of having this on the denominator, now we have it on our numerator. So ln of R2 over R1, we multiply that by our temperature difference, Ts1 minus Ts2, and that is all over. That is all over ating 2 pi L K, and then we have Ts1 minus Ts2. And it's pretty nice since you can just cancel yung ating temperature difference. So, and therefore, no, therefore, yung ating resistance, yung ating thermal resistance in a cylindrical system is defined by the ln of the radius, or the radii R2 over R1 all over yung product ng ating circumference, no, the circumferential area and the thermal conductivity 2 pi L K. And yun. So we have 3 governing equations for a cylindrical system. So thermal, tabi na natin. Resistance in a cylindrical system. And so we have formulated 3 equations. And so, and this is just a derivation, and there are problems where you still have to manipulate some values here and there. But so I hope you guys have learned something. And so uh, I guess we will use this in the class later. So I'll just send it or whatever. And I guess that's it. So thank you guys, and goodbye. I'll see you again when I have something to derive or something I want to upload. Ayan. So, goodbye.